Earthspan.
Hello, learners. Today, we are going to discuss refrigeration cycle in the simplest way we can. The refrigeration cycle is derived from the Carnot cycle and is sometimes called the reversed Carnot cycle, which is why its components are the same as the said cycle. Like any cycle, the refrigeration cycle has its medium, or substance, or working fluid that flows throughout the cycle. This fluid is called the refrigerant. There are plenty of refrigerants available today, but the common refrigerants used in air conditioning units are the R22 or known as Freon and R410A or also known as Boron. So why do we use refrigerants for this type of system? It is because of these basic characteristics. Refrigerants have low freezing point. It means it should not freeze easily. Low condensing pressure to condense easily. Low boiling point to phase change into vapor easily. High latent heat of vaporization so that larger energy or heat can be extracted. Of course, non-toxic, non-inflammable, non-explosive, and non-corrosive. So now let's move on to the main components of this cycle or system. Just like other thermodynamic cycles, refrigerant cycle has 4 components, which here are the compressor, condenser, expansion valve, and evaporator. Let's discuss them one by one. Let's start with the compressor. Here at the compressor, we compress the vapor refrigerant, increasing its pressure and temperature. The purpose of this is to convey or move the refrigerant throughout the system. As we all know, by the second law of thermodynamics, in order for particles or matter to move, we need a difference in energy level. The matter moves from higher to lower energy levels. In this case, from higher pressure to lower pressure. So next is the condenser. On this component, the vapor refrigerant changes phase into liquid, so it becomes a liquid refrigerant. Its temperature decreases but the pressure remains the same since this is a heat exchanger. We all know heat exchanger follows an isobaric process, which means that pressure is constant. The main purpose for this component is through condensation, we remove a larger amount of heat from the refrigerant. Why? Because it extracts a lot of energy or latent heat when we change phase compared to just heat transfer without phase change. After the condenser is the expansion valve. The refrigerant enters the expansion valve as a liquid and exits as a mixture of liquid and partly vapor. This happens because the expansion valve regulates the flow rate of refrigerant that enters the evaporator. Through regulation, the expansion valve lowers the pressure of the refrigerant and so it lowers the temperature needed for it to vaporize. The lower the pressure, the lower the boiling point. In addition, the expansion valve ensures that the refrigerant exiting the evaporator is a superheat and no liquid is present as liquids are incompressible, which means the compressor that compresses cannot compress this fluid, which will result in damage to the compressor. Finally, the last component, the evaporator. By its name, the evaporator's function is to evaporate or vaporize the refrigerant. Through an evaporator fan, the evaporator absorbs the heat from the air that the fan blows and thereby increasing the refrigerant's temperature. The increase in refrigerant temperature will vaporize the refrigerant. Evaporator utilizes the concept of latent heat of vaporization. Latent heat of evaporization is the heat required to convert liquid into vapor. The heat transfer through this is much greater than the normal heat transfer without fluid phase change. Now, since the refrigerant has taken a lot of energy from the air that exits the evaporator will be at a low temperature, and this is the air that we feel inside our rooms or houses. And that concludes our video. We hope you have enjoyed the whole discussion. Once again, this is Earth Pen. Learning has never been this easy for anyone, anywhere. Have a nice day.